So in this video, we'll look at exceptions, and in specific, exception trapping. Let's just begin by talking about something that we already know. When you make an error in your code, Python's going to tell you about it, and it's going to tell you by raising an exception. So let's look at an example of what might raise an exception. If I said val equals 5 and I said print val with two L's, obviously that's going to create a problem. The problem is VALL doesn't exist. Val does, but VALL does not. And this raises an exception. We're all familiar with these. We've seen them many times. This particular exception is something called a name error. The name error means that the name VALL wasn't defined in the code. Obviously it was because of a typo, and that's why we got the error. Now there are many such exceptions that we might encounter, and you've seen, I'm sure, your share of those so far. But I'm going to start to talk about errors as being one of two categories. There's really two categories of errors. And the two categories of errors are unanticipated errors and also anticipated errors. Now, what kind of error could be anticipated? That is, we know that it might occur. The unanticipated ones we're not ready for. When they occur, we take a look at our code and we try to fix them. But there are certain types of errors that can be anticipated. We know that they can occur. And I'll give you a simple example. Let's say we ask the user for a number. Now, hopefully by now you know what type we're going to receive from input as a return value from input. Input always returns a string no matter what, and it doesn't matter if the user types numbers, they're still going to come in as a string, something we learned in the first session of this class. So clearly, if we were interested in converting that string to a number, let's say we get a string and let's say 5, and we're interested in converting that string to a number and hopefully getting 5, we're going to expect that the user will type a number. If we're intending to convert that string to an int, it had better be a number, otherwise we might have a problem. What's the problem that could happen? Well, first we can run this and test it properly and see that it didn't give an error. Maybe I'll go ahead and do something with the number. So hopefully if I enter 5, I'll get 10. And I do. But what's going to happen if I don't type a number? Where will the error occur and what kind of error will occur? So if I don't type a number in input, what type of error will occur? And also, what line will the error occur on? Can you answer that question right now? Well, if we don't know, we can easily find out. And part of what we'll want to do in this session is find out what type of error occurs if we do run into such a problem like this one. Let's find out. I'm going to run this and I'm just going to say hello. In other words, to find out what type of error and what line number that error occurs on, I can simply make the error happen. That'll tell me. It looks like it's happening on line 7. That's the line that you see here. And it's a value error. Okay. Now we need to know this because there is another way for us, there's a certain way we can handle an error like this. But I might ask you a question. If I wanted to avoid this problem of if the user types hello, we're going to get a value error. How could I do that? How could I make this program bulletproof against that possibility that the user might type a bad value? Well, we've done it in earlier sessions. You could check to see if the user's input was correct. You could use isDigit to check to see and make sure. If not isDigit, then exit with error. We could certainly do that, and that would work, and there's certainly nothing wrong with doing that. However, we would like to be able to handle an error like this. We want to be able to handle an exception like this, and in fact, we want to be able to do it without having to check ahead of time whether it's okay. In this case, you can see that we're getting a value error, and in this case, right now, we're getting it on line 4. What we can do is we can trap the error. The way we do that is we identify the line upon which the error is expected to be raised. And we also identify the type of error. So I want you to use this in the future. I'm going to have to make something else happen. I'll do this in a second. I'd like you to keep this in mind. Make the error happen. Find out what type of error. Find out what line the error occurs. If you'd like to do exception trapping on a line, you need to know what kind of error will occur, and you need to know on what line it will occur. And when we did our experiment, we found out that it would be this line, and it would be a value error. If that's the case, what we can do is create an except block, a try block around the line where we're expecting the error, an except block that says what to do if this error occurs. In this case, it's saying, let's just set a default value for IX. Instead of making it the user's number, which doesn't work because they typed hello, let's make it 0. And if we do that, then our program will be able to both handle an error, like if I say hello and it'll give me 0, or can also handle if I do the right thing. If I put in 55, I get 110. The way it works is this. When Python enters the try block, it's ready to trap an exception if the right exception occurs. When the exception occurs, Python notes that it's in the try block, looks to the except block and says, is this the exception I was looking for? If it is, then it goes ahead and executes what's in the block. In other words, try except is almost like an if block. If the error occurs, execute what's in this block. So we could very well put this under flow control. If a certain condition occurs, execute the block. If it doesn't, then don't. So think about what happens if I type, let's say, a 5. What's going to happen with this program? Can you say? Well, if we type a 5, it's going to enter the try block, convert it to integer 5, and then it's going to drop down to here. But if we type hello, it's going to enter the try block. The value error will be raised when we try to convert to int, and then it will go on to the except block. Why don't we run this through the debugger to illustrate? When you do, so it's asking for input. Let's put in a 5. Oh, I didn't put in a breakpoint. I'm going to need to do that. Let's do that. Put a breakpoint right here. Always remember, you can't put a breakpoint on the very first line of code or it won't stop there. So we debug it. And it's asking us for a number, so let's put in 5. And now we enter the debugger and we're stopped on line 7. We know that X is a string and it's 5. Let's step into our code and we get to this line. Now this is the place where it's going to convert the string 5 to an int 5 without a problem. And let's see where it goes next. It jumps all the way down to the bottom. See that? It went straight from here to here because the value error did not occur. Let's run it again. Let's debug it again. and let's enter hello and find out what happens. So we type hello, we hit enter, enters the debugger and stops on line 7. Let's step into our code, jumps us to this line, or steps us down into this line. This is where we're expecting the exception to occur, right? If you try to convert hello to int, it's going to raise a value error. So now we go to the value error except block, into that block, and then we move on from there. So you can see again that try except is a little bit like an if else. If this happened, if this exception was raised, then enter the except block. If the exception was not raised, then skip over it. And this is the essence of trapping exceptions. We again identify make the error happen so we can see what type of error it is and also on what line the error occurs. And that's the procedure that I'm going to ask you to follow when I ask you to trap an error. Let's do another type of error. Let's say that I had a dictionary. And this dictionary has values, and I'd like to ask the user for a key. Now let's follow the prescription that I gave earlier, this multi-step process. I'm going to go ahead and print the value. Here, let's call this key. And I'm now going to print the value for the key in the dictionary. Now, my first question to you is, what error could occur? Where could this error occur? Well, if you think about it, and if you know, dictionaries will raise an exception if the key can't be found in the dictionary. I should say that Python will raise this exception. If Python can't find the key in the dictionary, it's going to raise an exception. Now the question is, what type of exception will be raised, and on what line will it be raised? Again, we can make the error happen to find out. Of course, you may know already, and that would work fine. But let's make the error happen. Let's first test this correctly. We should see 2. If we give it a B, we should see 2. Let's run it again. And let's give it a key that doesn't exist. Now we see what the exception type is, and we see the line on which the exception occurred. Can you see the exception type from what you're seeing right here? It's a key error exception. That's right. It's called a key error, and it's raised anytime a key can't be found in a dictionary. All right. On what line did it occur? It's line 7, correct? Okay. So now we can go even further. Wrap the error line in a try block. In the except block below, identify the exception. Now you must always do this. There are some students that realize that they can use the word except by itself, and you are not to do that. But I'll illustrate that in a second. Let's wrap the error line in a try block, and let's use an except block and identify the exception. Again, what's the name of the exception? It's called key error. And now let's do something, let's say not found. So now we have identified the exception, we know what line it's on, we wrap that line in the try block, and then we use the error type with except to trap the error. And here I'm just going to print done. So let's run it, and let's see if you can tell me, where is it going to go if I put in a correct key, and where is it going to go if I put in a bad key? Let's talk about the correct key. It's going to go from this line to this line to this line to this line. And the question I have for you is, let's say that I put in the key B, or let's say the key A. I put in the key A. Where is it going to go next? Well, if I put in the key A, it's going to jump from line 10 to line 14 because the exception did not occur. Next question. What if I run the program again and I put in the key X? It's going to go 7, 8, 9, 10. I'm going to attempt to look up the value for the key X. It's going to take me here, then here, and then here. Let's try it. I'll run this with a correct key, A, and it gives me 1 and done, right? So it jumped to here, from here down to here, from 10 to 14. And we'll run it again and give it a bad key. And now it says not found. So it went from here to here to here and then done. So again, you can see that this is a form of program flow in which we determine which line will be executed next depending on the conditions. The only difference, of course, is that the condition is raised by Python and we're trapping it. So we don't have a test in here, no if test, but in a sense, this line is sort of like the if test. It's basically saying, if this raises a key error, continue with this except block. So as long as you're following the steps that we have here, you can trap any exception. You need to follow it very carefully though, and especially there's 2 special admonishments that I'd like to make. The first is that, let's put in 2 special caveats. Wrap try around fewest number of lines. And the second, must identify the error type. Now let me show you exactly what it would look like to violate these 2 special requirements. One would be to be putting lines that don't belong in the try block. Now there's no one that's going to stop you from doing this, and so I need to make it a special requirement. The special requirement is wrap the try around the fewest number of lines. In other words, there's nothing to stop you from putting your whole program in a try block. But the problem with that is that it doesn't effectively show the reader where the exception is expected, because it could be anywhere. I guess this done really doesn't belong here because clearly we want it to say done no matter what. But why shouldn't I put this line and this line into the try block? The answer is because we're not expecting a key error on those lines. The try block has to be around just the lines of code that make sense as far as the exception goes. These lines don't belong there because they're not raising an exception. And if you put them there, and especially what I've seen is a student will put his or her entire program into a try block. And that is kind of crazy because if you put your entire program in the try block, then whoever's looking at your code has no idea where the exception is expected and would have to pick through your lines trying to figure it out. Why do we want them to know? Because we want these exceptions to be very visibly trapping an error on a very specific line, because it helps the reader understand where the problem might be and what to look out for. The second big requirement is that you identify the error type. Some of you may find that you can just say except. You may even see except in some answer online. This is a big problem. It will work, and that's the big problem with it. it will totally work, just like the other one will work. I can put in a bad key and and it will trap its exception, and it totally works. But what's wrong with this? Well, first off, it doesn't effectively identify the type of error that I'm looking for. I want the reader to look at this and know which line we're going to get the error, and also what kind of error we're expecting. But the other big problem with this, with saying except, and the other one is except exception. This is also prohibited. The other big problem with this is that it could be trapping errors that we're not aware of. Let's say I was to have a name error in here. And let's say that I just put in a correct key and it says not found. Can you see why it says not found? Even though A is there, it's not getting the value. Why? Because I got a name error here. This trapped it, and then it just ignored it. So it would be very easy to trip yourself up by saying except or except exception, because those two idioms, except and except exception, will trap any error. And so certain unexpected errors may get trapped, and you wouldn't know. You wouldn't know what the problem is, and you could get very, very confused. Whereas if I were to put key error here, which is the correct exception, the one that I'm looking for, and I run this code and I give it an A, it's going to tell me about the name error. You see? It didn't trap the key error because a name error exception was raised. And so this allowed the exception to show itself and tell us what the real problem was here. Okay, so what to come away with are these 5 steps and these 2 requirements. When you want to trap an exception, you'll follow the 5 steps. And before you're done and moving on to something else, you'll look at the 2 requirements to make sure that they are also followed. And that's exceptions. We'll be using it more in the future as well. This is just the beginning, but now you know how we like to trap exceptions. It's often preferred over checking to make sure everything's good before proceeding. It's usually better to trap it after it happened. Okay.